Good afternoon, council members. My name is Nathan Ray, and I'd like to briefly discuss how fire prevention protects lives, properties, and our community. Fire prevention is much more than responding to emergencies. It involves education, enforcement, engineering, and cooperation between the fire department, builders, and the public at large. First, I want to start off with education, enforcement, and engineering. Education can be broken down into a public awareness, school programs, smoke alarms, and exit planning. Those are pretty straightforward. We need the public to be aware of the dangers that exist and how our methods to mitigate these dangers lead to a safer workplace, home, and public gathering locations. School programs focus obviously on children. Smoke alarms not only function in residential houses, but also in larger buildings that have fire protection systems. And then exit planning. Well, if you have an emergency of any type, but especially a fire, there has to be a means of egress. Those all are brought to people's attention, and then they know exactly what to do when emergencies arise. The enforcement mechanism. So locally in this jurisdiction, we rely on the county code enforcement to handle the enforcement of fire-related codes. So for different types of structures, there are different things. For those that are open, the locations that are open to the public, fire inspections are required prior to organizations being able to utilize a building for the public to meet. These inspections look for some of those types of things we mentioned earlier, those being ingress and egress, as well as fire protection systems or smoke alarms. There are times when people are building buildings or renovating, they have to file permits. These permits are for the building itself, but it also encompasses any updates that need to be made to make the facility safe, and that triggers the inspection process before anyone can occupy the building. Code compliance is highly important and helps to maintain the standards that keep the public safe. Going right along with that is the engineering aspect. These buildings have to be designed to hold the people that will be there. And they have to be designed for the systems to work properly together. So building design may take in anything from the materials that the building is made out of to how the sprinkler system is routed to make sure that it operates correctly, that the fire pump system has the most robust means of electrical service so that it doesn't fail during an emergency. Make sure that the fire alarm system functions properly and is tied into the sprinkler system, as well as fire-resistant construction. This is highly important, especially in buildings where public gatherings are held or in multi-family units. Think of apartment buildings, condos, something like that, where you don't want fire to spread between one location and another. Fire-resistant construction is kind of a layered approach. It doesn't mean that there's one item that won't burn. It means that there are assemblies that are built up to protect people. That may be the assembly of just a standard wooden 2x4 wall with gypsum drywall on both sides that reduces the spread of fire, all the way up to significantly longer duration firewalls that are rated for maybe a generator install within a large facility that has backup power. There may be a multi-hour rating on that to make sure that any fire that's created cannot spread to the rest of the building and allow people to exit, or it can't spread to adjacent buildings. So our jurisdiction enforces the adopted fire codes through inspections, permit reviews, compliance investigations, and follow-up inspections. If there are issues, there are follow-ups to make sure that those are mitigated. Anytime people have inspections, they have areas where there are failures to comply with different parts of the code. There's a follow-up that comes from that allows them to mitigate the issues, and then we can come back in and verify that the occupancy will be safe. We do occasionally run into continued non-compliance, and that does result in citations and other enforcement actions. That's not something we try to focus on. We'd like to give everybody an opportunity to mitigate the risks that exist, but there are instances where businesses or public operating facilities have to be closed down, or temporarily or possibly permanently, if they're unwilling to meet the standards. So next I want to move on to a big distinction as new versus existing locations. Everything new must meet the current code. Existing facilities are usually grandfathered in unless a permit is pulled for renovation or changes, and that triggers them to be brought into compliance with the most up-to-date code. What is the most up-to-date code? Where does that come from? Is that something we made up? No, absolutely not. So there's a couple of things that we draw on, not only for the code itself, but also for what meets the code. There's a couple of organizations that I want to mention. One is the National Fire Protection Association, and they establish fire code, sprinkler system, life safety code standards that are voluntarily adopted by local jurisdictions. These help to reduce the risk and improve occupant safety. The International Code Council develops the IBC, or the International Building Code, that is also voluntarily adopted for building design and construction. Think of things like fire protection systems and means of egress to make sure that a building isn't built with one door in and one door out and the windows aren't operable. Or you can't rely on windows to be a means of egress if we've got a multi-story building. There has to be a fire escape. There has to be a means for people to exit regardless of where you're at, above or below grade. Next, I want to touch on some of the actual materials themselves. Well, how do we know that a wooden wall with gypsum covering is going to hold up? Well, we have somewhere like ASTM or UL. ASTM is the international now. It used to be the American Society of Testing and Materials. They test wall assemblies. They test specific equipment to make sure that it holds up to 1, 2, 3, 4 hour fire rating, whatever's required for the install. And it's usually done as an assembly. So, think of the previously stated wall, or a CMU, a concrete masonry unit wall, where penetrations where piping may go through it are sealed up with fire-rated materials to make sure that you don't have fire that spreads beyond the assembly before the rated time frame. Underwriters Laboratories does similar type testing for wall assemblies or enclosures, and that helps to establish the baseline for what fire resistance is and how it can be applied to buildings. So the testing goes along with this. ASTM has their E119, which is kind of the gold standard. It covers lots of information for wall assemblies and building assemblies. It's also important to remember, it's not just a wall. It may be a roof. It may be a floor. It may be between units. So the wall between units is much more important than just a partition wall between a living space and a bathroom. If it is in a multi-story building, it may need to withstand much more than just a partition wall. Or it may be protecting something more important. So your stairwells and elevator corridors are usually grouped together and have a much higher fire rating than a partition wall, because you want those to stand longer to allow everybody the proper means of egress. So let's talk a little bit about what's verified when these inspections come in. So they're going to verify fire doors, that the doors are rated properly, that doors can be closed to keep a fire from spreading, and that they function with the wall system that's there. Because a wall system is great and may have a good fire rating, but if the doors are left open, it really doesn't do much good. Penetrations to those walls, we've already mentioned that. There may be blocking within walls, depending on the type. And then ceilings, floors, all of those work as a combined unit. So what are our most unsafe structures? Well, generally speaking, wood frame construction, but there's more than just that. It comes down to wood frame construction that is aging. And by aging, it may be the stuff that's not the most up to code. It may be the stuff that's the oldest. So there are a lot of areas where we have legacy buildings, and these have the least means of fire protection, whether it be egress, sprinkler systems, alarms, any of those. So those create the highest dangers in our city, but those are also the ones that are brought up to code when they're renovated or when changes are made. And so that's why we have this process in place. It works as a loop that anytime things change, they get brought up to speed. If the use case changes, then a building maybe have more requirements than it used to. We do have also dangers that arise around abandoned buildings or neglected buildings, blight. So sometimes there may be times where owners are forced to come in and provide upgrades or make a change to a facility because it poses an undue risk to those in the general vicinity around them. They may have a failing roof system or deteriorated stairs, or it may just be a public nuisance where there may be some sort of vagrancy on site, and we don't want that to pose a problem to the other buildings within that vicinity. So a special use case of fire safety is actually modern construction. So there are modern construction assemblies beyond your general wood frame construction, where you may have trusses. There may be floor trusses, there may be ceiling trusses, and those are great engineering tools to provide clear spans, to reduce construction costs, but they do have some drawbacks from a fire protection standpoint. So those drawbacks may be that they don't hold up as long under the same type of a fire. Maybe you have a floor system, and if it was an old stick framed joist system in residential construction, let's say, it may last for an hour or two, given the assembly the way it's built. But because of the way the connections are made on a truss system, fire can damage those and cause the floor system to fail prematurely. So there are scenarios where additional fireproofing, there may be fire-rated lumber that's required to be added to that, or additional fire blocking to make those standards come up to speed. Because the last thing we want to do is have a wonderful, structurally designed system that fails and doesn't allow people the proper time of egress, or it fails when our first responders are trying to clear a building and we have a roof come down or a floor system fail while they're trying to help occupants exit the facility. So hopefully you can see from this that this is a collaborative approach. It's multifaceted. It involves the fire department, the public, code enforcement, and of course the builders and contractors who make these facilities come to life. So all of these things come together to help us provide safety for the public at large. Thank you.